In lesson 7.4, you will evaluate logarithms. In our first examples, we're going to rewrite the equation in logarithmic form. The equation is given in exponential form. And you can see that these equations have a base raised to a power, an exponent, and it's equal to some value, some number. Well, that can be changed to logarithmic form by solving for that exponent. That exponent 3 is equal to log base 2 of 8. Those two equations, one in exponential form and the other in logarithmic form, say the same thing. So in problem 2, to change this exponential form to logarithmic form, all we have to do is solve for that exponent. That exponent 4 is equal to log base 3 of 81. And number 3, that exponent x is equal to log base 7 of y. And number 4, in general, that exponent x is equal to log base b of y. And we can go the other direction too. We can start with and write the form. So we can take that first equation, log base 3 of 9 equals 2, and we can change it to exponential form. The base is 3, it's raised to the power of 2 to get 9. And you can see that that's a true statement. 3 squared is equal to 9. So whether we state it in logarithmic form or exponential form, we get the same statement, just in different forms. Okay, problem 2, our base is 8. It's raised to the 0 power to equal 1. And we know that anything to the 0 power is equal to 1. So log base 8 of 1 is equal to 0 is the same as 8 to the 0 power equals 1. Now the third problem, log base 5 of 1/25 is equal to negative 2. That says the same thing as what? Our base is 5. Our exponent is negative 2, and that's equal to 1/25. And we know that that's true also because to get rid of this negative 2 exponent, we'd have to move 5 to the denominator of a fraction and make the exponent positive. So we'd have 1/5 squared, which is 1/25. Okay, here we're going to evaluate the logarithm. So all we have to do to evaluate a logarithm, log base 4 of 64, is change from logarithmic form to exponential form. This log is just an exponent. Let's call it y. So this equation says 4 to the y power is equal to 64. Well, we know that 4 has to be raised to the third power to get 64. So this log just has a value of 3. Okay, how about the next one, number 2? Let's say that this log is equal to x. So our base is 2 raised to the x power is equal to 1/8. Now in order to get a fraction out of 2 to the x power, that exponent would have to be negative, so that 2 would have to be moved to the denominator of a fraction and raised to what power? How many factors of 2 are in 8? And that would be 3. So 2 to the negative third power is equal to 1/8. That's a true statement. So this log base 2 of 1/8, just has a value of negative 3. Okay, problem 3, doing the same thing. let's say this is equal to n, this log base 1/4 of 256. So our base is 1/4. It's raised to the n power, and it's equal to 256. Well, what power do we have to raise 1/4 to in order to get 256? Again, if we're going to get that 4 out of the denominator, we're going to have to make the exponent negative. And then how many factors of 4 are in 256? That would be 4 factors of 4. So if we raise 1/4 to the -4 power, we're going to get 256. So this log has a value of -4. Okay, problem 4. Let's let this log be, well, let's go back to y again. Okay, so this says the same thing as 32, that's our base, raised to the y power, the log is just an exponent, is equal to 2. Well, what power are we going to have to raise 32 to get 2? Okay, now I know that I have to go from 32 to something smaller to something 2. So now I'm going to ask myself, how many factors of 2 are in 32? And I know that there's 5 factors of 2 in 32. So I'm going to raise 32 to the 1/5 power in order to get 2. Because 32 to the 1/5 power is the same as the 5th root of 32. And the 5th root of 32 is equal to 2. So this log just has a value of 1/5. Okay, log base 10 of 7. If you don't see a base, you know that that base is our common logarithm, common base of 10. Now this has a value, let's say x, that we're looking for the power that we raise 10 to in order to get 7. Well, we can think about what that value would have to be close to, because if we raise 10 to the 0 power, anything to the 0 power is 1, and if we raise 10 to the first power, that has a value of 10. So we're looking for something we can raise 10 to get 7, which is between 1 and 10. So that exponent is going to be between 0 and 1. And to find that exponent, we can use our calculator. We can approximate our exponent using the calculator because we have a log key on our scientific calculator. So use your log key on your scientific calculator and take the log of 7. Now that value is going to be approximately 0.845. We're going to round our exponents here to 3 decimal places. So I'm getting 0.845 for the power that I would raise 10 to get 7. Now let's try this one. This is our natural logarithm, natural log base e, and let's say that that has a value of n. So we're raising e to the nth power in order to get 1/4. And again, we're going to use our calculator to evaluate this power that we raise e to get 1/4. E is an irrational number, and we have a ln key or log base e key on our calculator, so use that now and take the ln of 1/4. So I'm getting negative 0.386 for a value for n. 6 is the power that you raise e to get 1/4. Okay, on this last page we're going to simplify expressions. We're going to simplify the expression 10 raised to the log of x power. So let's just let this equation again equal some variable, or this expression equal some variable, say y, and let's go from exponential form this time to logarithmic form in order to solve for x, or to simplify this expression. So this equation says the same thing as log base 10, and we don't have to show that base when it's our common log of 10. So log base 10 of y is equal to that exponent log of x. But if log base 10 of y is equal to log base 10 of x, those numbers have to be the same. So y has to equal x in order for this to be true. So this expression, 10 to the log of x power, is equal to x. It just simplifies to x. Okay, let's try problem 2. Let's say that this equals n. So now we can go from logarithmic form to exponential form. Our base is 5. Our exponent is that log, n, and it's equal to 125 to the x power. But 125 has 3 factors of 5 in it, so I can write 125 as 5 cubed raised to the x power. And now I have double power, so I can multiply. So I have 5 to the n power is equal to 5 to the 3x power. So that means if my bases are the same on both sides of this equation, then the exponents have to be the same, or n is equal to 3x. And now solving for this log base 5 of 125 to the x power, that logarithmic expression is just equal to 3x. Okay, let's try problem 3. Let's say this is equal to x. And so this expression can be simplified to what? This exponential equation has the same form, or is equal to the same logarithmic form as log base e, which is just ln. So ln of x is equal to ln of 9, is equal to that exponent. So if the logs are the same on both sides, log base e or ln on both sides, then x has to equal 9. Then those numbers have to be the same. So this log e to the ln of 9 power is just equal to 9. Okay, and the last one, let's say this is equal to y. And so our base is 3. We're going to go from logarithmic form to exponential form. Our base is 3 raised to the y power, and it's equal to 27 to the x power. So again, there's 3 factors of 3 in 27, so we can write 27 as 3 cubed raised to the x power. And now double powers we'd multiply, so 3 to the y power is equal to 3 to the 3x power. And our bases are the same again on both sides of this equation, so that means y has to equal 3x. So, going back to the problem, log base 3 of 27 to the x power just has a value of 3x. Include with your notes of this video guided practice problems 2 through 12 even on pages 499 and 501 of your textbook.